Okay, this is question number 10. We are given the matrix W as 3, 6, negative 2 and 5. Determine the 2 by 2 matrix L such that W plus L is 0, 0, 0, 0. Okay, so solution, since W plus L is 0, 0, 0, 0 and W is equal to 3, 6, negative 2, 5, hence we now have, in place of W you substitute 3, 6, negative 2, 5 plus L, this is required 0, 0, 0. Okay, this is a 2 by 2, 0, 0, 0, 0, 0. So therefore L is equal to 0, 0, 0, 0 minus, move this matrix to the other side, 3, 6, negative 2, 5. So this is equal to 0, negative 3, 0, negative 6, 0, negative of negative, that's positive, 0, negative 5. Okay, why am I showing you this? In case you have elements here, then you will have to follow this concept or this principle. So this is equal to negative 3, negative 6, 2 and negative 5. Therefore L is equal to negative 3, negative 6, 2 and negative 5. So this is a solution to this question. Now this is the next question. You have to find 2 by 2 matrix P such that WP is given as 1, 0, 0, 1. Okay, this is a solution. Given that WP is 1, 0, 0, 1, this means P is equal to W inverse. You move this W to the other side, it becomes W inverse multiplied with 1, 0, 0, 1. So now we need to find W inverse. So W inverse is nothing but the adjoint of W divided by determinant of W. So to get the adjoint of W, we have to go use the matrix W. W is 3, 6, negative 2, 5. So we interchange the elements. 5 goes to the position of 3, 3 goes to the position of 5, and then we multiply a negative sign along the left side. So that's going to be positive 2 and negative 6. Now we need to get the determinant of W. That is nothing but 3 multiplied with 5. When we are multiplying along this left side, we take a negative sign. So this is going to be negative 2 times 6. 3 5s are 15, negative is positive, 6 times 2 is 12, so we get 27. So determinant of W is 27. So therefore W inverse is nothing but 1 over 27 times 5, negative 6, 2 and 3. But this is not at over, we need to get P. So P is W inverse of 1, 0, 0, 1, which is nothing but 1 over 27, 5, negative 6, 2 and 3 and 1, 0, 0, 1. Row multiplied with column, so 1 over 27 is retained. So this is going to be 5 times 1 plus of negative 6 times 0. Row multiplied with column, 2 times of 1 plus of 3 times of 0. Row multiplied with column, 5 times of 0 plus of negative 6 times of 1. Row multiplied with column, 2 times of 0 plus 3 times of 1. So parenthesis, so this is equal to 1 over 27. We add up the elements. 5 times 1 is 5, 0 times negative 6 is 0, no need to place that. 2 times 1 is 2, 5 times 0 is 0, 6 times negative 6 times 1 is negative 6, 2 times 0 is 0, 3 times 1 is 3. So this is what you get for the matrix P. Okay, so -6 is there. So let's move on. Okay, this is the next question. Right angled triangle M as vertices x of 1, 1, y of 3, 1, z of 3, 4. When M is transformed by the matrix n equal to 0, 1, 1, 0, the image of M is M dash. We are asked to find the coordinates of M dash. Okay, so the understanding here is N is the matrix which is responsible for the transformation. Now let us consider a coordinate, say xy. Now N is operating on xy to give us x dash and y dash. So that means 0, 1, 1, 0 times xy is equal to row multiplied with the column. So 0 times x plus 1 times y, row multiplied by the column. So 1 times x plus 0 times y. This is equal to 0 and y, 1 times x and 0. So this is what we get. So therefore xy is transformed to y and x. So they're asking what is the new transformation when we apply this. So x of 1, 1 will be transformed to x dash. Now x becomes y, y becomes x. So this is going to be 1, 1. Similarly, y of 3, 1 is transformed to y dash of 1, 3. Now z of 3, 4 is transformed to z dash of 4, 3. So that is the solution for this beautiful question. Now this is the next question. We are given a triangle OPQ such that OP vector is 3 times u and OQ vector is v. Q is the midpoint of OR and M is the midpoint of PQ. So let me draw the diagram. Okay, so we have the triangle like this. And this is POQ and OQ is V vector and OP is 3U. Now we are given that L is a point on OP such that OL is 2 over 3 times OP. Now we are asked to find LM vector. Now since OL is 2 over 3 times of OP, this means 2 over 3 times of OP is 3 times U. So this 3 and 3 gets cancelled. So let me write this. So 2 over 3 of 3 times of U, 3 gets cancelled, giving you 2 times U. So therefore OL vector is 2 times U. So if I take this point as say L, right, so out of this entire region, this region is going to be my u vector, and this region is going to be 2 times u. Okay, so extend this. So this is R, and M is the Q is the midpoint of OR. So extend a little bit further. So Q is the midpoint of OR, and M is the midpoint of PQ. Right? So this is what we have got. So now we have to get LM. Now LM vector has to be got. Now what is LM vector? Now LM vector is M vector minus L vector. Now we need M vector. M is the midpoint, so that means half times P vector plus Q vector, because M is the midpoint of PQ. But P vector is 3 times U, and Q vector is V. So M vector is 1 over 2 times of 3 times U positive V. And L vector, we have L vector to be as 2 times U. Right, we just found that. Also L vector is 2 times U. So from here, therefore LM vector is equal to half times of 3 times U positive V, this is for M, minus 2 times of U. So this is equal to 3 over 2 times of U minus 2 times of U plus V. This is going to give you minus, right, 4U negative 3U. That's minus U divided by 2 positive V. So this is my LM vector. Okay, next they want us to find the PR vector. Now before we could find a PR vector, we need the R vector component. So OR vector, I'm going to use OR vector, is nothing but 2 times of OQ vector. But OQ vector is V. So therefore OR vector is 2 times of V. Right? So therefore PR vector is equal to R vector minus P vector. R vector is 2 times V, and P vector is 3 times of U. So this is what we have got, right? So therefore PR vector is 2 times V negative 3 times U. So that's the solution for that question. Okay, this is the next question. We are asked to show that LMR are all collinear. Now for this we have to recall the value of LM vector, which is nothing but half times of negative U positive V, and recall LR vector, which is 2 times V negative 2 times U. Now if I can rewrite this as 2 times of negative U positive V, then it would be much better for us. So from here, LR vector is 2 times of negative U positive V. See, negative U positive V, you can rewrite this. This means negative U positive V is 2 times of LM, right? So in place of negative U positive V, I can substitute 2 times of LM vector. So this is nothing but 4 times of LM vector, which is equal to LR vector. Okay, so what is the meaning of this? This means that LR vector is a scalar multiple of LM vector. So once you have established this means that LMR are collinear, hence the result. Okay students, this completes the run through and the study of January 2021 paper CXC, and until we meet again, please like, share and subscribe. Thank you.